Good morning, grade 8s, and welcome to WorksheetCloud Maths. My name is Jo Milligan. I hope you are all well today, and I wish you a very happy Earth Day. And remember, although today is officially Earth Day should be every day for us because we should be looking after our environment every single day. Right, we're going to go on to algebraic expressions today. Algebraic equations today. We have already done algebraic expressions, and the difference is that now we're going to look at how to keep a scale balanced, okay, using an equation. So what is the difference between an expression and an equation? Well, an expression has an unknown value, and in order to find its value, you need to know what the unknown value or variable is. So for example, 10x plus 3, we can't do anything with it because we don't know the value of the unknown, the value of the variable, which in this case is x. Okay, x is the variable, we don't know its value, the expression has to stay as it is. But if we get given the value, so say we're told that the value is 5, then we can say that 10 times 5 plus 3, and we can get the value of the whole expression, which is 53. So we can evaluate the expression. Okay? But what is the difference? An equation, on the other hand, can be worked out because we are given the value of the expression. So in other words, the output number is being given to us. And then we can manipulate the whole equation to find out what the x is. But remember, it has to be balanced on both sides. So what you do to the one side, you must do to the other side. And the whole point is to get x on its own to find out what the value of x is. So, like it said, this equation needs to remain balanced. So in order to work out what the x is, we need to eliminate the other values equally from both sides. Remember, if you've got a scale and you add something to one side and not to the other side, it's going to become unbalanced. We need to keep this equation balanced at all times. So what we do to the one side, we have to do to the other side. And the whole point of trying to work this out is to get x on its own. So if we have a look at this step by step, there's our equation. We've got 10x plus 3 is equal to 53. We want x on its own so we can find out its value. So what do? We would take away that 3 on this side, but we have to do the same on the other side. So there we go, 10x plus 3 minus 3, which means that we have to take away the 3 on the other side. Can you see? We've kept it balanced. If we only took away the 3 on the one side, it wouldn't be balanced and the equation wouldn't work out. So 10x is then equal to 50. Now we have to divide this side by 10 and that side by 10 so that we can have x on its own, just like that. Can you see how we've kept the equation balanced? Then we're going to end up with x is equal to 5. Now we mustn't just leave it there and say, okay, well that's fine, x is equal to 5. Let's check it. Okay, and by checking it, we're going to substitute back into the original equation. So we would go, you can see that our answer is 5. We've said that x is equal to 5. Let's put 5 back into the original equation. So we'd go 10 times 5 plus 3. We can see that it's going to be 53, but let's just go through the motions. Okay, 10 times 5 is 50, plus 3 is 53. It works. Well done. Right, let's look at another one together. And this time we're going to be starting from a given statement, in other words, a word statement. So the statement is a number added to 85 is 90. We now need to make up an equation from that. And there's your equation. X plus 85 is equal to 90. Now remember, we want to leave x on its own. So in order to do that, we're going to say 85 minus 85 on this side, but we have to do the same on this side to keep it balanced. And x is equal to 5. How do we check? We then substitute back in 5 in place of x, so 5 plus 85 is equal to 90. 90 and 90 balance, our scale is balanced, so yay, we've got it right. That means that x is equal to 5. That is correct. Okay, now you try one and then we'll go over it together. There's your one to try. Pause the video, work it out on a piece of paper, and then we'll go over it together. Right, how did you do? that would be x divided by 4. So divide a number by 4 to get to 12. X divided by 4 is equal 12. We've now got to try and get rid of the x on this side. Sorry, not the x. We've got to get rid of the other values so that x stays on its own. And in order to do that, we will use the inverse operation or the opposite operation. So what's opposite to divide? It would be multiply. What we do on the one side, we do on the other side, because we have to keep the scale balanced. So x divided by 4 times 4, and then we have to do the same on the other side, 12 times 4. So what are we going to get? X is equal to 48. Okay, now we check it by substituting. We're going to put 48 in the place of the x. 48 divided by 4, what does that equal? 12. 12 is on the other side. Yay, it works. Scale is balanced, which means that 48 is correct. 48 is the value of x. Right, here's some more to try. You can write these down, try them on a piece of paper, pause the video, and then we'll go over them one by one together. Right, how did you do? Let's have a look at the first one. Twice a number is 100. So we've got 2x is equal to 100. How do we get rid of the 2? It's 2 times x, so we must divide by 2, which means we have to do the same to the other side. 2x divided by 2 is equal to 100 divided by 2, which means that x is equal to 50. Let's substitute in to check that it's right. 2 times 50 is equal to 100. Right, there we go. Our scale is balanced. We've got it right, which means that the 50 is the correct answer of x. Remember that this is not the answer for x. That is your double check. This means that that is the answer for x. If that is correct, what you've done in this section means that you have got it right. If you are confident and you don't need to do a substitution, that's fine. But if you're a little bit wary and the answer doesn't look quite right, substitute it back in to double check yourself. Let's look at number 2. Half a number is 15. Right? We've got half x is equal to 15. What we need to do now, the inverse of that half would be to times it by 2. Remember, half x is the same as x over 2 or x divided by 2. Okay, so we would go half x times 2 is equal to 15 times 2 because we've got to keep that scale balanced, which means that x is equal to 30. Okay, substitute it back in. Half 30 is equal to 15. Both sides of the scale are balanced. Therefore, you are right, and x is actually 30. Number 3, let's see how you did here. 4 plus a number is 23. 4 plus x is equal to 23 would be your equation. Again, we've got a positive 4 there, which means we have to take 4 away on that side of the x. On the left-hand side, we have to take 4 away on the right-hand side too. So there we go. 4 plus x minus 4 is equal to 23 minus 4. So these two 4's would then disappear, and you would have this to work out on this side. So x is equal to 19. Let's put 19 back in to substitute. We just want to make sure every single time that our scale is balanced. 4 plus 19, that gives you 23. 23 is the same on the other side. You've got it right, which means that x is equal to 19. Let's look at the last one. 93 added to a number is minus 3. Right? 93 plus x is equal to minus 3. Let's remember, get rid of the 93 on that side, which means we have to do the same to the other side. So what we do to the left-hand side has to be the same as the right-hand side. So we've got 93 plus x minus 93, which is equal to minus 3 minus 93. So it's going to be x is equal to minus 96. That doesn't look quite right, so let's check it. 93 minus 96 is equal to minus 3. That means 93 minus 96 is minus 3, which is the same as on this side. So even though it looked a bit funny, it is correct. You have dealt with negative numbers, so this shouldn't be too much of a mission. It means that x is minus 96, and that is correct. Okay, Right, let's go one step further. This is a bit of a challenge because now we're going to introduce unknown values to both sides of the equation. So you can also have variables on either side of the equal sign. For example, 10x minus 7 is equal to 5x plus 3. Maybe it looks a little bit daunting to you, maybe it looks a little bit difficult, but let's just use the same things that we've done all the time and let's work through it carefully. So the first thing, we need to get all our variables onto the same side of the equation and all the constants onto the other side. But we will do it step by step. As you go along and you get used to this, you can do it all in one step, but let's try it step by step for now. Right, we've got 10x minus 7 minus 5x. Can you see we've taken the variable across, but we're going to do minus 5x because on this side we did minus 5x to get rid of that 5x there. So we're going to be left just with the constant. Okay, so we've got 5x minus 7 because 10x minus 5x gives me 5x. Keep the minus 7 because we haven't done anything with that. And we've got a 3 left there. Now we've got to get 5x on its own. We're used to working with something that looks like this. So we've got to take away the 7 by adding on 7, and we'll add on 7 to that side. Okay, so all our constants to the other side. There we can see minus 7 plus 7 is going to give us 0. But we have to add on 7 to keep our scale balanced. So we're going to end up with 10 on this side and 5x on the other side. We're not yet finished. We need to have x on its own. So how do we get x on its own? We're going to divide by 5 here, which means we have to divide by 5 on that side, just like that. So we're going to end up with x on its own, and x is equal to 2. So I think a good thing would be to substitute, because that was quite a long process. Let's make sure it works. Okay, 10x minus 7 is equal to 5x plus 3. We've got to substitute for both values of x, not just the one. So we're going to substitute 2 in here, we're going to substitute 2 in there, and we're going to get 10 times 2 minus 7 and 5 times 2 plus 3. Let's see, we've got 20 minus 7 and 10 plus 3, and we're going to get 13 on both sides. It works. See, if that is balanced, then it means that that is correct. Okay, let's try another one together. 9 minus x is equal to 2x plus 3. We've got to get all our x's on one side and all our constants on the other side. So let's add on x to this side, and we'll have to add on x to that side, which means that we're going to be left with 9 on the left-hand side and 3x, because we've got 2x plus x on the right-hand side, but we haven't done anything with that plus 3 yet. So let's try and move that to the other side so that all our constants are on the same side, which means that we'll do minus 3 here, and we'll do a minus 3 on that side. We're going to end up with 6 on the left-hand side and 3x on the right-hand side. Divide this by 3, divide that by 3, and you're going to get x is equal to 2. It doesn't matter whether your x is on the right-hand side or the left-hand side, you've got it as being equal to 2. To check, let's substitute in 9 minus x equals 2x plus 3. Remember, we have to substitute in for both x's. So we're going to get 9 minus 2 is equal to 2 times 2 plus 3. 9 minus 2 is 7. 2 times 2 is 4 plus 3. 7 is equal to 7. Yay, we've got it right. Now we need to try these. You need to try these on your own. You can pause the video, try those on a piece of paper, and we will go over them together. Right, let's have a look. How did you do? The first one, 5x plus 3 is equal to 9 minus x. Can you see we have taken that x across by adding it onto this side, and you add it onto that side. Then we will get 6x plus 3 is equal to 9. Can you see how that has just made that x disappear, and we've taken across to this side? Okay, we now have to take that constant and put it on the right hand side. So to do that, we're going to say plus 3 minus 3, we're going to end up with 6x there. Then that we'd have to say minus 3 like we did it there, and 9 minus 3 is 6, and x is equal to 1. Okay, let's see by substitution. We take the 1, we're going to put it back into our original equation by substituting it. 5 times 1 plus 3 is equal to 9 minus 1. 5 plus 3 is 8. 9 minus 1 is 8. Yay, it's right. That means that x is equal to 1. Okay? The next one, 2x plus 3 is equal to x plus 4. 2x plus 3 minus 3. X plus 4 minus 3. Can you see we've kept the scale balanced completely? We've got 2x on its own and x plus 1 on the other side. That means we need to take that x away and we need to put it on this side. So what if we minus it here? We've got to minus it there. So we've got 1 left on this side and x left on that side. I think that tick is a little bit premature, but let's have a look by substituting it in. We're going to take the 1, we're going to substitute it in. 2 times 1 plus 3, substitute it in on the side, 1 plus 4. 2 times 1 is 2. 2 plus 3 is equal to 5. And we have got a balanced scale, which means that your x is correct. Let's look at the next one. Right. 10 minus 3x is equal to 3x minus 2. 10, we've got to get rid of the 3x on this side. Let's take it across because it is a negative. So then it becomes a positive and it's much easier to work with. It's not saying you can't work with a negative, but let's take the negatives across to this side. Okay, so we're going to try and take that across. We're going to say minus 3x plus 3x, and we've got a plus 3x on that side as well. So we're left with 10 on the left-hand side. 6x because it's 3x plus 3x over here, but we've still got minus 2. Let's try and get our constants to the right side, and so in order to do that we've got to add on 2 here, which means we add on 2 there, which means we have 12 on the left hand side, 6x on the right hand side. We've got to get x on its own. How do we do that? We divide by 6 on the right hand side, divide by 6 on the left hand side, and we're going to end up with 2 is equal to x. Let's have a look if we can substitute. Does that work? 10 minus 3 times 2, which is going to give me 10 minus 6, and on this side it's 4. Here we've got 3 times 2 minus 2, which is 6 minus 2, it's 4. Hooray! That is right. Okay, remember again, just to go over it again, this is not your answer for 6. This is your double check to make sure that your scale is balanced. That would be your answer to x. If this is balanced, then x is right. The value of x is right. Okay, let's look at the next one. 3x minus 2 is equal to x plus 4. 3x minus 2 minus x, we're going to take that x away from here. So there we've minused it, and we've minused it here. Keep the scale balanced, remember. We end up with 4 on the right hand side and 2x minus 2 on the left hand side. So now we've got to get rid of this 2. We're going to add it to the left hand side and add it to the right hand side. We're going to end up with 2x is equal to 6. We want x on its own. So if we've got 2x, we've got to divide it by 2 and divide that by 2, divide the right hand side by 2, x is equal to 3. If you're not sure if it's right, if you're 100% sure that it is right, then you can leave it there. If you're not sure it's right, check by substitution. Here we've taken our 3, we've put it back into our original equation, into the right places. 3 times 3 is 9. 9 minus 2 is 7 on the left hand side. 3 plus 4 is 7 on the right hand side. It balances. Yay, x is equal to 3. Right, guys, thank you for watching the video. Thank you for being part of WorksheetCloud. Have a wonderful day further, and remember to celebrate Earth Day. See you next time.